Welcome everyone. Let's continue our discussion of organic chemistry. We have so far looked at hydrocarbons, we have looked at alkenes, alkanes, and alkynes. There's also another group of organic compounds that we call alcohols, and we are going to look at them, what makes them unique, what is their functional group, how do we name them, do they actually exhibit isomerism, and if they do so, what type of isomerism do they exhibit, how do we prepare alcohols? Okay, we'll look at that, and then finally we will look at the chemical reactions, and then we will also look at the impact of alcohol on the body, on the human body. What are the effects of alcohol on the human body? Okay, so that is going to be our presentation. Alcohols, we can also call them alkanols. Okay, what is actually very distinguishing with them is that there is the functional group that we call the hydroxyl group, the OH group here. Okay, that is actually their functional group. Okay, remember the functional group is a group of atoms that actually determine the chemical properties of a particular organic compound. Okay, so we are saying that in alcohols, or in what we call alkanols, we have the OH or the hydroxyl group as the functional group. It is attached to a saturated carbon atom. Okay, it's attached to a saturated carbon atom there. Okay, so the general formula is CN H2N plus 1 and then OH. So this is to say that if N is let us say N is 3. If N is 3, then we shall be writing that using this general formula. We shall basically be having C with the 3 there, okay, and then H with 2 times N plus 1. So since N is 3, that will be 6 plus 1, that will be 7. Okay, and then the OH there. So basically, do we have the same thing here? Do we have propanol? Yes, we have propanol. Remember, if we have 3 carbon atoms, then that is PR, okay, propene, propane, things like that. So this is propanol, okay, propanol here. So this is exactly that, okay. So when N is equal to 1, then this is what you get, methanol. If N is equal to 2, it will be ethanol. If N is equal to 3, propanol. And then if N is equal to 4, butanol. And then propanol if, and in pentanol if we have N equaling to 5. Okay, now I have not been mentioning this one here. I guess you know what this one means. Yes, that one actually means the position of the functional group, the OH. Okay, so here it is basically indicating to us that the position is on carbon atom 1. Okay, yes, that's quite very important there. So how do we name these alcohols? We basically follow usually these similar rules, okay, similar rules of naming organic compounds. Okay, so let's look at these rules once again. So what we do is that in case we have an alkane, we remove the E and replace it with OH, or we mean with OL, and replace it with OL, such that if we have For example, ethane, this is what you have. Replace this E with the OL. So what we definitely come up with is ethanol, right? With ethanol. That's rule number one. Okay, so whether it is propane, just replace that with this. Okay, butanol and then the rest pentanol. Now, that's rule number one. That means that when you mention a name of an alcohol, definitely the person will be able to know that this is an alcohol we are talking about because of that OL at the end. And then we come to the rule number two, which is identify the longest continuous carbon chain that contains the OH group as the parent chain. Remember, organic compounds exhibit what we call branching. Okay, branching is when you, for example, have carbon, 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 carbon properly there, and then you have some branching here, and then you have another CH3, for example, there. Okay, so these ones are basically like that, and then like that. So assuming you have an OH here, that basically means that it is an alcohol. So what we are saying is that identify the longest chain that contains the OH group. Okay, that contains the OH group. Identify it. It is what will tell you whether you use the word, whether you use prefixes such as propane, for example, butane, or not that. Let me repeat this, editor, not that. So that will be what will actually tell you whether you'll have but, that is 4 carbon atoms in the longer chain, or pro. Okay, that P. Remember, if we have 1 carbon atom, we have that. We can call that a methyl group. So in that a methyl group, for example, BCH3, this is basically referring to this 1 carbon atom. But we can have 2. Okay, we can have 2. So if we have 2, then we use that ethyl group, whatever you can call it. But we use that. We use also ethene, for example. We use ethanol, right? So this basically here is to basically emphasize that those are 2 carbon atoms that you have in that. So the reason as to why we need to identify the longest chain that contains the OH group is because we want to know whether we use which suffix, okay? I mean which prefix. Is it but? Is it pro? Is it ethyne or methyl? Okay, we are only considering that the longest chain that contains the functional group OH in this case. Hope that is quite clear. So of course, after you have identified, then you give it a name. The naming of the carbon atom, the numbering of the carbon atom is you start from the one which is lowest to the functional group. So basically, you start from the functional group side, counting away. Okay. So if you want to put the position of the functional group, so for example here, this is actually 1. This is carbon atom 1. This is 2. D3, this is 4. You don't say this is 1. No, it is farthest. This one is actually, you don't say this is 1 because this is farthest. It is far away from the carbon atom that contains the functional group, that is bonding to the functional group. Okay, so you give the name according to that. So since this one actually is the one that contains the functional group, then you have 1, 2, 3, 4. This is the longest. Right? You disregard this branching. That branching, you will indicate it as with the position. So you say you will indicate the position of that branching. Okay, you will indicate the position of that branching. That's where you see where you have a compound that has about 2 figures in it. One figure is indicating where the branching is, one figure is indicating where the functional group is. Okay, so you indicate the position of the OH group, which is the functional group in that case, and any other subsequence by number. It is exactly what I've just been explaining. Okay, so indicate the position of the functional group, and if there is any branching, indicate that branching also. So here, methanol, 1 carbon atom, and then the OH has to be there. So you basically have, let's write this. So you have 1 carbon atom. Make sure that you have the OH group, and then make sure this is actually completely, you have the 4 bonds. And so you have the H, you have the H, you have the H. Okay, so that is why you have C, 1 carbon atom, plus the 3, and then the OH. Okay, so that is where you have that. That's where you have that. Okay, so with ethanol, 2 carbon atoms, and then add the OH, and then make it full with the hydrogen atoms. So you have 2 carbon atoms, 2 carbon atoms, and that OH. And then make sure that these are actually filled. All the bonds are there. 4 bonds are there for each carbon atom. Okay, so H, 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 so you can see the first carbon atom here on this side is having 3, right? 3 hydrogen. The second has 2. And then the OH. Yeah, so that is ethanol. Okay, so you can go on and go on. Propanol, butanol, and then pentanol. Remember, there is isomerism from propanol going to butanol, going to pentanol, because you can, from propanol, that's when you can shift the position of the OH. Okay, you can move it to another carbon atom. So here now, propanol 1-ol, that is propane 1-ol, which is basically propanol, is this means that you have the OH group on the first carbon atom. okay, on the first carbon atom, but you can also have it on the second, okay, yeah. So that is basically what I've just explained is what we call isomerism. When you have the same organic compound, but with the same molecular formula, but different structural formulas. Okay, this is because some of the groups of the compound can be moved from one place to another, such that it looks different, but basically the molecular formula remains the same. So like I said, we only have isomerism when we only have isomerism when the alcohol has at least 3 carbon atoms, and that's why we said we start with propanol. Okay, with the ethanol, regardless of whether where you place the OH group, it will always remain the same. With that one, it will be the same thing. So you can't have. With methanol you cannot have, with ethanol you cannot have. But going further, when you have more carbon atoms, then you can have isomerism happening. And this type of isomerism is what we call positional isomerism, where the OH group can be placed on different carbon atoms. So alcohols can be classified into 3, depending on the position of the OH, well, that is the hydroxyl group, okay? So here, for primary alcohols, if the OH is only bonded to only one carbon atom, for example, in propanol, that is primary alcohol, if it is the OH group is attached to 2 other carbon atoms, then that is what we call a secondary alcohol. With tertiary alcohol, the OH group is attached to 3 other carbon atoms. So as ethanol, ethanol is what we want to basically base our discussions on going forward. We are going to look at, of course, its properties, how we actually manufacture it, and then we'll also look at the effects it has on human bodies, and also the chemical reactions, and how we also prepare it. That's what we are going to look at. So it is basically what we want to focus on here going forward. So we can also call it ethyl alcohol or grain alcohol. I believe that you have seen alcohol being made in your village, where banana or grain are mixed in a particular way to make this alcoholic drink. That is basically ethanol. Okay, it is colorless, it is volatile, and boils at a temperature of 78 degrees centigrade. That means that it boils at a lower temperature than water, which boils at 100 degrees centigrade. So there are 2 ways in which this ethanol can be prepared. That way, the one I've just outlined in the village, and then this way where we actually make it by passing ethene through concentrated sulfuric acid under pressure to form what we call ethyl hydrogen sulfate, and then passing that with diluted, you dilute that with water and then heat, and then you get your ethanol here and the sulfuric acid being regenerated. And basically what we can say is that the overall reaction is this: ethene with water, you get alcohol. Okay, but the process is that you start with passing the ethene through concentrated sulfuric acid under pressure to form ethyl hydrogen sulfate, and then from there the ethyl hydrogen sulfate is diluted with water and then heated again, and then the reaction that happens there is hydrolysis, and that's when you have the ethanol and the sulfuric acid again. Okay. Now, the other way we make alcohol, for example, even at home, you can actually do this, even at industrial level, and that process is basically what we call fermentation. Okay, that is what we call fermentation. So with fermentation, you basically convert. What happens is that the carbohydrates or starch or the sugars are basically converted into ethanol and carbon dioxide under anaerobic conditions. What that means is that where there is no sufficient oxygen. Okay, where there is no sufficient oxygen. So this is our traditional way of making ethanol in the village, for example. Okay, so the method is basically simple. What you get the source of this glucose. Remember, I talked about starch or carbohydrates generally. These ones can be converted into, let us say, simple sugar, sucrose or glucose, and then add yeast to that, and then add some water, and then cover tightly, and then leave for some days, and then you go and check, and you have an alcoholic drink there. So this is basically what we are trying to illustrate. That covering of the pot, we actually usually use a pot. You get a pot, put there yeast, put there your squeezed juice from the cup. It could be from the banana, it can be from any source, and then cover that. Okay, leave it. Usually it is covered in the ground. Okay, the pot, and then check it after 2 or 3 days, and that's how it is basically made. But here, what we are emphasizing is that you have this kind of lime water, this little bit advanced, and then you have what we call air lock apparatus. So what basically happens in there is that you need to have a source of carbohydrate. This can be the banana, it can be the potatoes, it can be the corn, and the first thing is to make sure that these are converted into glucose, and the process is hydrolysis, breakdown to release this sugar. And then this reaction, the conversion of this glucose into ethanol requires an enzyme. And that enzyme is actually what we get from the yeast. That is why yeast is actually added in there. Okay, so what you basically have is that the glucose is converted into ethanol and carbon dioxide. Okay, so the limitation of fermentation is that what you get is actually crude. It is not very concentrated, so it has low ethanol concentration due to yeast toxicity and at higher concentration. That's one of the limitations of fermentation. Okay, and that the what you get actually is not pure, so you may need to carry out distillation such that you have a pure ethanol. Okay, and carbon dioxide. So those are the 2 ways in which ethanol can be made. The chemical reactions of ethanol are not quite many, but we can go through them very fast. The first one is that ethanol actually burns completely in air to produce carbon dioxide and water. Carbon dioxide and water, and this is the equation there. And then the next reaction that we can talk about is what we call dehydration. The dehydration reaction, what we saw earlier on, is coming back here. When you get an alcohol, you react it with concentrated sulfuric acid, you will form ethyl hydrogen sulfate, isn't it? Yes. So when you heat that again, you actually form ethene and water. So this is actually one of the ways that we saw for making ethene. Okay, dehydration of alcohol using concentrated sulfuric acid is one of the ways of preparing ethene. So we'll look at, for example, simple distillation, which is basically here. Simple distillation, this is aimed at making sure that we separate ethanol from, for example, water, the things that are making it impure. Okay, so what you do is you get your ethanol, which contains the water and other impurities. Then you heat that. When you heat it, when it reaches 78 degrees centigrade, that's the boiling point of the ethanol. So you boil and then, of course, condense, and then you collect it. So what you basically collect here is pure or concentrated ethanol. Okay, concentrated ethanol. Okay, so you take it away. Okay, and then what remains is the water, because it has not yet reached its boiling point. This setup is what we saw in what we call the separation of mixtures. So one of the ways of separation of miscible liquids or mixtures is simple distillation, and we are also seeing it here that we can use it to basically have concentrated ethanol. So we want to compare how we make ethanol. We said that we can use ethene with concentrated sulfuric acid and get ethanol. We also say that we can ferment carbohydrate sources and get ethanol. So we want to look at the comparison. The raw material that we use for fermentation of carbohydrates, for hydration of ethene, we have ethene as the raw material there. In fermentation, we use yeast for the enzyme, and then phosphoric acid is what we need in hydration of ethene to get ethanol. And then fermentation is a biological process, and then the hydration of ethene to get ethanol is actually a chemical process. Ethanol concentration, the product that we get using fermentation, is actually low in terms of concentration, but also in terms of purity, it's also low. That is the opposite in terms of hydration of ethene to get ethanol. You get high ethanol concentration, and also you get high product purity. Yeah, like I said, we can get ethanol from different carbohydrate sources, millet, banana, and many other things. Okay, so this ethanol can be used for a number of processes for making alcoholic drinks at actual industrial level, and it can be used in paints, varnishes, and other industrial applications. It can also be used as biofuel, as an alternative for gasoline, and then what we use to clean our hands as antiseptic, what we call sanitizers these days. And then because of its low boiling point and large change in volume temperature, in volume with temperature, ethanol can be used as in thermometers as a thermometric. Ethanol has that thermometric property. Okay. People who consume alcohol and they cannot stop, and that even their social life, even their professional life becomes altered. We say that these people are actually addicted to alcohol. Okay, they are addicted to alcohol. These people are addicted to alcohol. When they are addicted to alcohol, that means that they cannot do something productive if they don't take any alcohol. So it comes as a result of taking alcohol over and over again, and then your body depends on it, and then you slip into addiction. Okay, addiction is not good because every money that you get, you spend it on alcohol. Your family relations, you will not be having very strong ties or bonds with your family, and also social. You actually cause a lot of chaos. Cases of domestic violence increase, and engaging in risky behavior also increase. It can also result into abandoning children. You don't take care of your children, you beat everyone. So alcohol has really negative impact when you take it excessively. Okay, but on your health, alcohol basically affects almost each and every organ. Each and every organ. The liver, the brain, the heart, even your blood cells. You can easily get anemia. Your the testosterone levels go down. That reduces libido. And then if you're pregnant and then you take alcohol, your child can get what you call fetal alcohol syndrome. And then you also have when you take alcohol, the urge to go and urinate becomes increased. Okay, so that is the diuretic effect of alcohol. So alcohol basically is not good. Whatever amount that you take, it will have consequences on your body, and also your family and the society at large. That marks the end of this presentation, where we have looked at alcohols. We say that they are actually organic compounds that have a functional group, hydroxyl group, that we call the hydroxyl group. It is basically the O and the H. Okay, these can be positioned differently in different compounds, and when we name them, we look at the longest chain that contains the hydroxyl group. Okay, the naming does not necessarily differ from other compounds, and we have said that we manufacture it using two major ways. Okay, where we get ethene and react it with concentrated sulfuric acid, we get ethanol, or we can do what we call fermentation. Okay, and the reactions of ethanol are quite many, but one that also stands out is when we get ethanol and burn it, that burn produces carbon dioxide and water. Thank you for listening.